stall, 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 stall.
The power-off stall is also known as the approach stall. The airplane is configured for landing with gear down and flaps full. This is a stall that is characterized by a sight picture that looks almost level. Because the pitch is not very pronounced, it is a stall whose onset usually surprises the pilot. The reason it is called an approach stall is because this type of stall usually occurs when a pilot is configured to land and begins to inadvertently try to stretch the glide as the airplane slows by increasing back pressure on the yoke. This type of stall can occur during an emergency power-off landing when the pilot becomes fixated on a landing area that is just beyond the gliding capability of the aircraft. The power-off stall usually occurs within 1,000 feet of the ground. For this reason, it is imperative that a pilot only lose the absolute minimum altitude during the recovery from the stall.
All right, so we're going to pick a point out horizon. We're going to take those mountains right there, very prominent, very easy to distinguish from the rest of the mountain range. We're 2,390 knots. We're going to go ahead and pull the power back to 15. Should know where that is on the throttle, so you're not taking a whole lot of time to do that. As soon as we're in the white arc, which we are, we're going to go flaps 10, 25, 40, and we're going to get to glide speed. We're going to go idle. We're going to glide for 3 seconds, 1 Mississippi, 2 Mississippi, 3 Mississippi, and then we're going to try to stretch the glide by holding our altitude.
Stall, stall.
And we want to go to a full stall,
stall,
which means the yoke's going to go all the way back. There's the brake.
Stall.
Power in, right rudder. Come back to the horizon. Release that first notch of flaps. And then we're pitching for VX. There's 64. Release that second notch of flaps. And then we're pitching for VY. Trying to maintain our heading. Lots of right rudder. As we come through 70, release the last notch of flaps. Flaps are up. We maintain VY and we continue to climb away. Okay, so you can see we did not lose our heading in that maneuver, and we did not push the nose below the horizon.
The power-on stall is also known as a departure stall. The aircraft is in a clean configuration with a high power setting simulating a takeoff scenario. This is the reason why the student does not begin pitching up until after slowing to a rotation speed of 63 knots. Outside of training, departure stalls can occur for many different reasons. Some of these reasons include an improper takeoff trim setting, a runaway electric trim, or a far aft CG. The departure stall can quickly surprise a pilot during this vulnerable phase of flight. The aircraft is very close to the ground and quickly losing airspeed in a nose-high attitude. The pilot must act very quickly to lower the nose and recover from the stall without sacrificing more altitude than is absolutely necessary.
All right, now we're going to do the power on stall. Okay, 2,300. We've got our heading on the Dos Cabezas, a very prominent point. We've got our bug set as a backup. And we're 2,300, looking for between 90 and 95. Okay, we'll reduce the power to 1,500. We'll hold our altitude as the airplane slows. Want to maintain that altitude, or the airplane will not slow down for you. Okay, there's rotation speed, pitch, right rudder, full power. Nose up to about 25, pitch up, wings level.
Stall.
Hold it till the actual stall. There's the stall, release the back pressure, lots of right rudder, maintain the heading, come back to about the horizon, reattach air to the wings, speed's increasing, back on heading, altitude, and now we can start to bring the power back to 2,300.
Note the distinct difference in the sight picture of a power-off stall on the left and a power-on stall on the right. When executing the power off stall, the pilot should never pitch more than 10 degrees nose up in order to correctly replicate the shallow pitch nature of this type of stall. If you have a wing drop during a stall, do not lift the wing with aileron. Doing so changes the camber of each wing, resulting in a higher AOA and deeper stall in the wing you are trying to raise. Additionally, adverse yaw is introduced by the asymmetrical drag of the wings. Both of these conditions, an asymmetrical stall of the wings and yaw, are exactly what is needed to induce a spin, as can be seen in this example. If a wing drop occurs, use opposite rudder to lift the wing.